Okay, so we now discuss about partial derivative rules. And in this situation, first recall what is the definition of a partial derivative. And in this case, we have some multivariable function, maybe x, y, z, dot, 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 of u. And we take the limit with respect to, or we take the partial derivative with respect to u, giving us f sub u of x, y, and z, and then wherever we have u. This leads us to a few of the rules that we've seen in single variable calculus, but extended to multivariable. So suppose you're given some x to the n, y to the n, plus y to the n, z to the n, u to the n. When we take the partial derivative with respect to x, y, z, and u are constants and so what we are left with is nx to the n minus 1. And a similar pattern follows for if we were to take a partial derivative with respect to y, ny to the n minus 1. So this is the power rule. And notice how it doesn't change. Here, suppose we have two functions that are dependent on x. Then by the product rule, it follows a similar pattern. Similar thing for quotient rule. And we finally have chain rule. Now, chain rule is a little bit tricky. However, it gets a little bit tricky mainly because we could have any number of independent variables that depend on another independent variables. So the way we can do this is by using tree branches. Let's suppose that you're given a multivariable function f of xy, where x is dependent on two variables. Suppose t and u, and y was also dependent on t and u. And these are independent variables which do not branch any further. The way we do this is, first, start with f of xy, branch it with its two independent variables, branch it again with t and u, t and u. Now, because we have two potential branches that we can go off to right after x and y, we have to use a partial derivative. So let's suppose we are asking, what's the partial derivative of f with respect to t? Well, we first look at every branch wherever there's x. So first we have f, and then it goes into branch of x. So we have the partial derivative of f with respect to x, and x branches one more time. So we have partial derivative of x with respect to t. Here we have one more branch. So we have partial derivative of f with respect to y, and partial derivative of y with respect to t. And from here, we construct a chain rule representation for this specific tree branch. So whenever we're given a multivariable chain rule problem, it is important for us to construct a tree branch for it so that we're able to find the partial derivative representation. And this is what makes multivariable into partial derivatives a bit tricky. But I hope you can see how we can use visuals to help us understand how to find answers to certain problems. Thank you. And in the next few series, we'll explore some problems, and so we can get a good understanding for partial derivatives. Thank you once again.